Determine the magnitude and y-intercept of resultant of force system acting on lamina as shown in figure. First, let us find out this angle phi. Phi is given by tan inverse of opposite by adjacent. So this angle will be phi and opposite will be this one and adjacent will be this one. So 22 by 2, 200 by 200. So phi we will get as 45 degrees. Now resolving all forces horizontally and vertically, summation fx and summation fy, 400 Newton. It is directed towards positive x-axis, so 400 Newton. Now for this force, it is 600 sine 45 degrees. It is directed towards positive x-axis, so 600 sine 45 degrees directed towards positive x-axis, so plus. Now for this force, it is 200 Newton. It is directed towards positive y-axis, so 200 Newtons. And this force is 600 cos 45 degrees. It is directed towards negative y-axis, so 600 cos 45 degrees directed towards negative y-axis, so minus. And calculating all this, we get summation fx value. Calculating all this, we get summation fy value. Resultant is given by r equal to square root of summation fx square plus summation fy square. Substituting summation fx and summation fy value, we get r value as 854.228 newtons. And resultant direction is given by theta equal to tan inverse of summation fy by summation fx. So theta we get as 15.22 degrees. So from summation fx and summation fy value, we see that summation fx is positive and summation fy is negative. So resultant will be 854.228 newtons and having a making angle of 15.22 degrees. So summation fx will be positive and summation fy will be negative in the fourth quadrant. So we can say that resultant is lying in fourth quadrant, but we don't know exact location where it is on this grid. To locate its exact location, now we have to take moments of all force components about some point, say it is O. So now taking moments of all forces about point O. So first taking moment of this force about O, it will have line of action like this, and it will pass through line of action of force, and it will have a perpendicular distance of 400 mm from point O like this. So it will have moment of magnitude 400 into 400, and it will rotate about point O like this. And this force will have line of action of force like this, and it will pass through line of action of force, and it will be passing through point O. So it will have 0 perpendicular distance about point O, and its moment about point O will be 0. Now this force will have line of action of force like this, and it will pass through line of action of force like this, and it will have 0 perpendicular distance about point O. So now this force will have line of action of force like this, and it will pass through line of action of force, and it will have perpendicular distance about point O like this. So 600 cos 45 degrees into 400. So this force is having magnitude of moment of 600 cos 45 into 400, and it will rotate about point O like this clockwise. So plus 600 cos 45 into 400. So Calculating all this, we get moment about O point, moment of all forces about point O, and D, that is perpendicular distance of resultant about point O, is given by summation of moment of all forces about O by R. Substituting values, we get D value. And x-intercept is given by summation MO by summation Fi. We get x-intercept. Y-intercept is given by summation MO by summation Fx. We get y-intercept. Now, what we have is summation Fx, summation Fi, R, theta, summation MO, x-intercept, y-intercept, and D value. So, x-intercept we have is 400 mm, y-intercept we have is 400 mm. So, resultant is having magnitude of 854.228 newtons, making angle of 15.22 degrees to the horizontal, and we can see that resultant is in the fourth quadrant with from point O having my perpendicular x-intercept of 400 mm and from point O having y-intercept of 400 mm, and this D distance D, this is the perpendicular distance D from point O.